Okay, so in this lesson we're going to be looking at finding an equation of a line. Now, we've already talked about slope-intercept form, y equals mx plus b, but we can only put information into that equation if we know the slope and if we know the y-intercept. But if we don't know those two pieces, which we usually won't, we're going to have to use a different form, and that's going to be the point-slope form. So if we're given a point in the line and the slope, that's when we can put it in this form. Or if we're given two coordinates, we can still put it in this form. We just have to figure out what the slope is from the two coordinates. But we'll look at that a little later. But first, let's make sure you know what the point-slope form is. It's y minus y1 equals m times x minus x1. Now, what's in red there is always going to be part of the equation. What the green part, the m, obviously that's your slope. The x1 and the y1, that is going to be the coordinates that they're going to give you. So let's actually start by looking at a story problem to see how this point-slope form is going to be used. So it says, in a physics experiment, a spring is 11 centimeters long with a 13-gram weight attached. Its length increases 0.5 centimeters with each additional gram of weight. This is a constant increase situation, so we're going to be continually increasing here, up to the spring's elastic limit. Write a formula relating spring length L and weight W, then graph the equation. So to start out with, we have some numbers. We have this 11 centimeters that represents the length of the spring when a 13-gram weight is attached. That's actually a coordinate. Okay. Now you want to make sure that you write this coordinate correctly, because how we write it is going to affect how we graph it, and it's going to affect our equation. So first off, what I realize is that they give us a graph here showing us that our weight is going to be our x-axis, and our L is going to be, or the length is going to be my y-axis. But let's say if you weren't given a graph, how can we figure out what's your x and what's your y? What you got to do is you got to think about dependent variable. Your dependent variable is your y. The weight doesn't depend on the length of the spring. The length of the spring depends on how much weight has been added. So the length, this 11 centimeters, that's going to be your y, and the weight is going to be your x. So I write this as a coordinate 1311. So that's super important to make sure that you get the coordinate figured out properly. Now its length increases 0.5 centimeters with each additional gram of weight. So that tells me that your rate of change, which is your slope, that's going to be 1/2. So now I just put it in the proper form. So it's going to be y minus your y1, which is 11, equals my slope, which is 0.5, times x minus my x1, which is 13. Now we don't leave it like this. We want to write it in slope-intercept form. And actually I'm going to go back in. Remember, y is your length. So I'm going to change this to be L. I'm going to change this to be W, because those are the variables they ask us to use here. But we want to get this in slope-intercept form. So the first thing I'm going to do is I'm going to distribute the 0.5 through. So this is a review of what we did back in chapter 1. And half of 13 is 6.5, so it'll be minus 6.5. Now I'm going to add 11 to both sides to get the L by itself. And negative 6.5 plus 11 would be 4.5. So this would be my equation. So to graph this, I know that my y-intercept, this would be a positive. Negative 6.5 plus 11 would be a positive 4.5. But I know now when I go to graph my equation, my y-intercept is at 4.5. 1, 2, 3, 4.5 would be right here. I know my slope is 1/2. What that means, from here I'd go up 1 and to the right 2. Now if you go up 1, that means you go up 1 whole unit. So I'd go from 4.5 up to 5.5, and then I'd go to the right 2. From here I'd go up 1 over 2, up 1 over 2. Or another way that we could have graphed this is I could have gone up here and I could have said, well, my coordinate was coordinate 1311. I could have found where 13 would be up to where 11 is and connect those. Otherwise, this would work too. So that would be your graph. So why don't you go ahead and take a second and do the same thing with this next problem. Again, make sure that you get your independent and dependent variables set up correctly. And so pause the video and hit play when you're ready to check your answer. Okay, so let's see how you did. So first off, a spring is 13 inches long when a 3-pound weight is attached. Remember, your weight is your x, because the weight depends on, or I'm sorry, the length of the spring depends on the weight, not the other way around. So this would be the coordinate 3, 23. Its length increases 3 inches with each additional pound of weight added. So what that means is that our slope is going to be, our change in y is going to be that it changes 3 inches for every 1 pound weight that's attached. So 3 over 1, or just 3, would be our slope. So when I go to set this up as an equation, it's going to be L, my y, minus my y1, which is 23, equals my slope of 3, times x minus my x1, which is also 3. And now we just solve this or rewrite this equation to be in slope-intercept form. So distribute the 3 through. Oops. And then we add 23 to both sides. And you get 3x plus 14 here. So if you go to graph that, your y-intercept here, now this one, here's again a note about graphing. If I count up to 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's not going to fit on the graph. So if you count by 2's, for example, so 2, 4, 6, 8, 10, 12, 14, 16, 18. Now what you want to be careful of now is when we go to graph this. I'm going to use count by 1's on the y-axis, because if I use slope-intercept form, my y-intercept is 14, which is right here, but my slope is 3. That does not mean that I go up 3 spots on my graph, 1, 2, 3. If I went up to here and then went over 1, that would be wrong. The reason why is because I'm not going up 3 units, I'm going up 6 units and over 1. Because remember, my scale here is I'm counting by 3's. I'm sorry, I'm counting by 2's. So if I were to go up 3 units, I'd go up 1, 2, 3 would actually be right here. And then over 1. I'd go up 1, 2, 3, over 1. Up 1, 2, 3, over 1. So this would be my graph. Oops. Let's see if I can do that a little better. Nope. Close enough. Okay, so you get hopefully you get the idea. Just make sure that when you go to graph these, that if you change the scale, if you're not counting by 1's, make sure that you make that adjustment when you're using your slope. Now, sometimes we're not given the point and the y-intercept. We're given just a coordinate, or just given 2 coordinates. If that's the case, what we're going to do is we're going to find the slope first. Okay, so what we're going to do is we're going to find an equation of a line going through these 2 points. So again, my first step is to figure out, well, what's my slope? So remember the slope formula, y2 minus y1 over x2 minus x1. Please make sure you're subtracting the y's first. So if I do this, this would be negative 2 minus 7 on top, 6 minus 4 on the bottom. Negative 2 minus 7 is a negative 9. 6 minus 4 is 2. Doesn't reduce, but it does simplify to be negative 4.5, which is a good decimal. Again, a note about decimals is if we change this to a decimal and you get a repeating decimal, please don't round it. Leave it as a fraction. So that'll be true for the next example that you do. Actually, we'll leave this as 15 and negative 2. So that way you can get some practice with that. Okay, so now I know my slope, and I have 2 points. It does not matter which points you use. Granted, when we start out putting it in point-slope form, it'll look a little different. But when we go and actually solve it and get it in slope-intercept form, you'll see that it doesn't matter which order you have it in. So for this one, I'm going to take, be y minus my y1. Let's use the 4 and the 7. So y minus 7 equals my slope of negative 4.5 times x minus 4. Distribute the 4.5 through. So it's going to be y minus 7 equals negative 4.5x. Negative 4.5 times negative 4 is going to be, let's see, that'd be a positive 18. Whoops. There we go. So it'll be negative 4.5x plus 18 there when you distribute the negative 4.5 through. And now we're going to add 7 to both sides. You get negative 4.5x plus 25. Now I just want to show you again that it doesn't matter which points you use, because if I would have used the other points, I would have taken y minus negative 2, which becomes y plus 2, equals my slope, which is negative 4.5, times x minus my x, which is 6. Because now if I distribute negative 4.5 through, negative 4.5 times negative 6 is a positive 27. But this time I would subtract 2 from both sides. Which gives me negative 4.5x plus 25. So again, it does not matter which order you do it in. Why don't you go ahead and try the next one on your own. Again, you can use either coordinate. You don't have to use both of them. Use either coordinate. And then press play when you're ready to check your answer. Okay, so first off, you should have found your slope. So your slope here would be, take negative 2 minus 4 over 15 minus 6. You do that, negative 6, 15 minus 6. Yeah, 15 minus 6 is 9. Reduce that. Remember, you always reduce your slope, becomes negative 2/3. Remember, if you do this as a decimal, you get 0.66667. But don't round this. Don't use 0.67 as your answer. You're going to have an inaccurate equation if that's the case. When you keep this as a fraction of negative 2/3. Okay, so next, we're going to put this in point slope form. So it'll be y minus, I'm going to use the 6 and the 4, so it'll be y minus 4 equals my slope, which is negative 2/3, times x minus 6. Distribute the 2/3 through. So when you do that, you get y minus 4 equals negative 2/3 x. Negative 2/3 times negative 6 gives you a positive 4. Add 4 to both sides, and you get y equals negative 2/3 x plus 8. Okay, so we're going to stop the video here. In the next video, we're going to talk about piecewise functions.